So Lewis structure is the key to know the figure of repulsion and the geometry of a molecule. The figure of repulsion is the drawing of all types of electron pairs around the central atom. And the electron pairs might be two types. The bonding pairs we called BP, and the non-bonding pairs we called NBP. Then the molecular shape or the geometry is deduced from the figure of repulsion by abstracting or by erasing the non-bonding pairs. So we obtain a certain form, and this form is the geometry. As we explained previously, the best method to know the figure of repulsion, then to deduce the geometry, is to transform the molecular formula to the simple form AXMEN, where A is the central atom, X the outer atom, M the number of outer atom, E the lone pair or the bonding pairs, and N is the number of E is the non-bonding pairs or the lone pairs, and N is the number of non-bonding pair. So they ask us to find the figure of repulsion of beryllium Cl2. The first step is to write correctly the Lewis structure. So this is the best Lewis structure for BeCl2. Then to deduce what is the form AXMEN. So it's AX2E0 or simply AX2. So we have two lone pairs in two balloons, and the best structure is when we have the minimum repulsions. So when these two lone pairs are 180 degrees. So any structure or any molecule, AX2 type or AX2E0 type, has, pay attention, from AX2, AXMEN, we deduce the figure of repulsion, has a figure of repulsion linear. And since we don't have E, we don't have non-bonding pairs, so the figure of repulsion is equal to the geometry, is the same as the geometry, and the geometry is linear. Then we talk about the angle outer atom, central atom, outer atom. So the angle CL is equal to 180 degrees. Now we pass to another form. When we have three EP, three electron pairs around the central atom, for example, BF3. So the boron has one bonding pair, another bonding pair, and third bonding pair. So we have EP equals 3. Or we can describe this structure as 3 lobes, each containing 2 electrons. When I say containing 2 electrons, that means this lobe or this balloon is the group of points where the probability to find these 2 electrons is maximum. So the best structure is when we have minimum repulsion. So if we have 3 balloons around the central atom or 3 lobes containing each 2 electrons, the minimum repulsion is when these 3 balloons make a structure in the plane as a triangle. So the structure, the figure of repulsion is trigonal planar. Trigonal, and this triangle is in a plane, so the figure of repulsion is a trigonal planar. Now we pass to the geometry. If we look to Lewis structure, EP equals 3, and the NBP, the non-bonding pairs, is equal to 0. So we don't have electron non-bonding pairs around B, so the figure of repulsion is the same as the geometry, and the geometry is trigonal planar, and the bond angle FBF is equal to 120 degrees. We pass to the form AXMEN. This is AX3 or AX3E0. So any molecular formula of the form AX3 or AX3E0 has a figure of repulsion FR, trigonal planar, and since we don't have non-bonding pair, so it has a geometry trigonal planar. Consider this structure. This is the Lewis structure for H2CO. If we look to the form AXMEN, AX3E0. The form is AX3E0. So directly, we can say, without doing all this analysis, that the figure of repulsion is a trigonal planar and the geometry is trigonal planar. And the angles in this case are close to 120 degrees. When we have 3 atoms of the same nature, so the repulsion between the lone pair, between the bonding pair of the first and the bonding pair of the second and the bonding pair of the third are the same, of the same strengths. So when we have the same 3 atoms, outer atoms, the angle is equal exactly 120 degrees. But when we have different outer atoms, we say that the angles are close to 120 degrees, and in this case is 121.9, 121.9, 116.2. Why the angle OCH is greater than HCH? Since the repulsion between the bonding electrons COCH is greater than the repulsion between bonding pairs CH-CH. We pass to EP equal 4. Consider CF4. We write Lewis structure, and we found that we have 4 bonding pairs around carbon and 0 non-bonding pair. So in this case, the EP equal 4. In other words, we have 4 balloons around the central atom C, and each balloon is the probability of presence of 2 electrons. So that the best structure is when the repulsions between the electron pairs is minimum. So the best structure is to have 4 balloons around the central atom in tetrahedral form. So the figure of repulsion for any central atom having EP equal 4 is tetrahedral. And since we don't have a non-bonding pair around the carbon, so the geometry is the same as the figure of repulsion, and we draw the structure by this way. This is the central. Around we have 4 outer, and the structure or the figure of repulsion with respect to the central is like a tetrahedron. So the structure is tetrahedral and the geometry is tetrahedral. So the bond angle in this case in the tetrahedral form is 109.5. What is AXMEN for this structure? For this structure, AXMEN is AX4 or AX4E0. So as a conclusion, any molecular formula of the type, of the simple type AX4 or AX4E0 has a figure of repulsion tetrahedral, and the geometry is also tetrahedral. We pass to the EP equal 5. Consider PCl5. When we draw Lewis structure, we obtain 5 outer atoms around phosphorus, and we have 5 bonds. And if you look now to the phosphorus, EP equal 5, so around phosphorus we have 10 electrons. And this is the extended octet rule. And as we said previously, in a block SP, we follow the octet rule when we are in the elements, when we use elements in the third row. So we can pass from the octet rule to the expanded octet rule, or the rule of 18 electrons. So we can have more than 8, and this is the case of PCl5. We will explain in the next chapter why phosphorus can have more than 8 electrons around. So in this case, EP equal 5. And in this EP equal 5, we have 5 bonding pair, 5 BP, and we have 0 NBP. In other words, we have 5 balloons that describe the motion of 10 electrons, and each lobe or each balloon is the motion or the scanner of 2 electrons. So the best structure is when we have a minimum repulsion. So the figure of repulsion in this case, if you look to this structure, we have 3 balloons in a plane, and we have 1 balloon perpendicular to this plane and another balloon which is also perpendicular. So the form is as bipyramid, and the basis is a triangle. So the figure of repulsion is a trigonal bipyramidal. And since we don't have NBP, so the figure of repulsion is the same as the geometry, and the geometry in this case is bipyramid triangle, or simply trigonal bipyramidal. This is the same, bipyramid triangle or trigonal bipyramidal. When we analyze this structure, we observe that we have 2 types of outer atom. We have 3 outer atoms in the plane, and we have 2 others, Cl, perpendicular to the plane. The outer atoms perpendicular to the plane are called the equatorial chlorine, or the equatorial outer atoms, and the Cl perpendicular to the plane are called the axial outer atom. So we have 2 types of angles. We have angle CLBP in the plane, and this angle is 120 degrees, because we see previously that when we have 3 outer atoms around the central in a plane, the angle is equal 120 degrees. And we have Cl equatorial, central atom, Cl axial, the angle is 90 degree. What is the type of this structure? The type is AXM, AX5, or AX5E0. So as a conclusion, if you have a molecule, you want to find the figure of repulsion and the geometry, you draw first Lewis, you transform it to AXMEN. Any structure that has the form AX5, the figure of repulsion is bipyramidal triangle or trigonal bipyramidal, and the geometry is also trigonal bipyramidal. And pay attention for the angles. We have two types. We have equatorial central, equatorial equal 120 degree, and equatorial central axial 90 degree, and axial central axial is equal 180 degree. We pass to the last arrangement, which is the octahedral arrangement. Consider as SF6 EP around sulfur is equal to 6, and in the 6 EPs we have non-bonding pair equal to 0 and bonding pair equal to 6. So around sulfur we have 2, 4, 6, 8, 10, 12 electrons, and this is the expanded octet rule. So in other words, we have 6 balloons containing each 2 electrons that are around the central atom. The best is to have 4 balloons in the plane that make a structure planar, square planar, and we have another lobe which is perpendicular to this plane and another lobe also perpendicular. So the structure is as octahedron or bipyramid. We have 2 pyramids, bipyramid, and the basis is square. So octahedral structure or bipyramid square. So this is the figure of repulsion. And since we don't have non-bonding pairs around the central, so the figure of repulsion is the geometry, and the geometry is octahedral. Also, we have 2 types of outer atoms. We have 4 outer atoms in the plane. So this is the equatorial ones. And we have 2 perpendicular to the plane. So this is the axial. F and F are axial outer atom, and the 4F in the plane are called equatorial. In this structure is symmetrical. So the angle equiaxial, central, equatorial is equal to 90 degree, and equatorial, central, equatorial is also equal to 90 degree. Axial, central, axial is 180 degree, since the axial fluorine are perpendicular to the plane. What is the type AXMEN? The type AXMEN is AX6 or AX6E0. So for any molecular formula of the type AX6 or AX6E0, the figure of repulsion is octahedral or bipyramid square, and also the geometry is octahedral or bipyramid square. So the summary How to find the figure of repulsion? First, we draw Lewis structure, then we calculate EP. EP is two types, is NBP and BP. If EP equal to, the formula is AX2 or AX2E0, and the figure of repulsion is linear, and the geometry is linear. For EP3, the figure of the repulsion and the geometry are trigonal planar. For EP4, the type is AX4 or AX4E0. The figure of repulsion and the geometry are tetrahedral. For EP5, the form is AX5 or AX5E0. The FR and GE are, pay attention, is, we have to correct, this is bi-pyramid triangle, and for EP equals 6, the geometry is, and the figure of repulsion is octahedral. So trigonal bi-pyramid is for this figure, and octahedral is for SF. Now, how to find the geometry? First of all, we learned how to find the figure of repulsion by transforming the molecular formula to the type AXM EN. Now we have to deduce the geometry. First of all, draw Lewis structure of the molecule. We have to follow the steps. Second, count the EP around the central atom, and the EP is bonding pairs and non-bonding pairs. And pay attention, this is very, very important. That will be explained in the next slides and in the next chapter, that the multiple bond around a central atom is counted as one EP. For example, if you have double bond A, B, and A is the central, this is counted as one EP. So the single bond and the double bond and the triple bond are counted as one EP in Vesper theory. Knowing the EP, we can find directly the figure of repulsion and not the geometry. And this is very important. The figure of repulsion is deduced directly from EP2 linear, EP3 trigonal planar, EP4 tetrahedral, EP5 trigonal bipyramid, EP6 octahedral. Now we have to find the geometry. In the figure of repulsion, we erase the lobes of the NBP, of the non-bonding pair. So by abstracting the non-bonding electrons, so by drawing only the bonding pairs, we obtain the geometry of the molecule. We noted GE. And pay attention, if you don't have non-bonding pairs around the central, the figure of repulsion is the same as the geometry. So this is how to find the figure of repulsion. Suppose an example, this is an example before explaining the other geometries. Suppose you have a form AX3E. That means EP around the central is equal to 4. We have 3 bonding pairs and we have 1 non-bonding pair. So EP around A is equal to 4 in this case. And for EP equal 4, the figure of repulsion is tetrahedral. So we draw 4 lobes. One lobe is A with X, the second A X, the third lobe is A X, and the fourth lobe is a balloon containing the non-bonding pair E. This is the figure of repulsion, which is tetrahedral. Now we have to pass to the geometry. The geometry, we have to abstract E, we have to erase the lobe of E, so we obtain a geometry which is trigonal pyramidal or pyramid triangle.